So now we are back in the new series named The Search of Shooting a Cat in the chapter 3 or like 2, in which we are talking about the X-rays, okay? So imagine a force surrounds you, flows through you, and even power your very existence, okay? You can't see it, hear it, or touch it. Yet this invisible power has transformed the world in an unimaginable way. Tonight, we are not just going into the science, we are uncovering a story of mystery, obsession, and courage. In this book, we read about the X-ray tonight, and I will like surprise you in a way in which we can't imagine how X-ray is. Okay, how quantum physics evolved in this world. So, a story that begins in a quiet corner of 19th century laboratories and lead to both miraculous discoveries and devastating consequences. Don't focus on this bullshit, okay? This is made by us, made in India, made by Heyman. Welcome to the tale of radiation. It was a chilly November evening in 1895. Listen to me carefully. This was a story made by me on the X ray, by which you can easily understand how X ray takes a big role in the quantum mechanics of past and today. You know about the X ray, man. So, it was a chilly November evening in 1895 when William Röntgen, a German physicist, stumbled upon something extraordinary. Röntgen was no stranger to the world of experimentations. His lab was a heaven of curiosity. His lab was very amazing, man. On this particular night, he was studying cathode rays, beams of electrons traveling through a vacuum tube, but something extraordinary caught by his eyes. And what that? I will tell you. The glow appeared from the tube, shaded by thick cardboard. He see a glow on the cardboard on the front of that ray that is emitted from the cathode ray tube. Okay, what could this mean? Integrated Rongston repeated the experiment, this time placing various objects between the tube and the screen. His heart must have raised when he held his hand before the glow and saw the shadow outline of his bones. Now he's shocked. He also don't know what he discovered, what he invented. Okay, bones without cutting, without surgery. He had just peered inside the human body without cutting it, without any surgery. You hear it? Okay. What is this? A new kind of ray? An X ray. Now, he called it X-ray because X means that unknown. He don't know what his name, what he will name it. Okay, and X-ray or cathode ray or like something like bones, like way, like emitted way that crossed by any object. So he called it X-ray, the unknown way. Okay, Longton discovered net showcased that the specific community, like scientific community, medical professionals celebrated the breakthrough using X-ray to diagnose broken bones, located bullets. Okay, for the first time in the humanity, glimpsed the invisible world, birthed out skin. But this way, but this was only the first chapter, the table of radiation. Okay, while the world was memorizing by X ray, another scientist was about to stumble upon an every even deeper mystery. Henry Becquerel. Henry Becquerel, Henry Becquerel, Henry Becquerel wasn't seeking fame. He was simple curious about the natural world. He wanted to see if certain material like uranium salt could emit X-ray when exposed to sunlight. Okay, but what happened next was pure serendipity. Okay, cloudy weather delayed his experiment. For days, the uranium sat in darkness, untouched. On Brockhill, mark my word, don't find mistake on my word. I'm not like very likely to the English, okay? So, Brockhill developed the photographic plate. He was astonished to find a ghostly image, even without sunlight. The uranium had emitted something powerful enough to penetrate the black paper and affect the plane. Mark my word, had emitted something powerful enough to penetrate the black paper and affect the plate. Okay, this this energy is coming from the uranium itself. Could it be a new kind of radiation? Broccoli had uncovered natural radioactivity, a phenomenon where certain elements emit invisible energy as they decay. This was a discovery that could change the world forever. So now, here's the radiation chapter comes from the X-ray. We are going to the radiation, in which we firstly discover that how radiation works and how it emitted from an object when it's decaying in a lone dark place at which there is no reaction happening, just radiation is emitting by the decaying of uranium, okay, and affecting the black paper and plane, okay, by doing nothing, only decaying. So that's how we see the first time the radiation and how it's work and how it affect the surrounding of itself, okay. So enter Marie and Perry Curie. Name these words, mark my words, okay. Henry Murray and Pierre Curie, a husband and wife team whose name would become synonymous and radioactive because they are very curious in the radioactivity. Okay, inspired by Broccoli's work, they set out to uncover more radioactive elements. Their passion was relentless. Their determination was unshakable. Okay, the Curies wasn't just brilliant. Okay, they were tireless, extracting tiny amounts of radioactive material from tons of ore was grueling work. Like because this is very hard work because you are finding radioactive elements from like a very big mine like that. Okay, so, day after day, they told their hands stained their bodies, unknowingly absorbing the radiation. Because if you are in the place where radiation is going on way, so you are also in the effectiveness of that radiation. So your body also absorbing some kind of amount of radiation. Okay, so they are the radiation affecting their body day by day by day, a little bit of little bit of little bit. Okay, the Curies discovered of radium brought team the Curie's discovery of radium brought them worldwide acclaim, okay? But it came at a price. They marveled at the soft, airy glow of their samples, unaware that the very glow was a sign of delaying radiation, deadly radiation. They don't know how radiation is harmful for their bodies and for their life, and they played with them. And now it's time the radiation played with them, okay? Years later, the toll of their work would become tragically clear. While the Curies unrevealed the mysteries of element, Ernest Rutherford, Ernest Rutherford, the father of nuclear physics, we know about that, okay, focused on the atom itself, okay. In 1909, his gold foil experiment, we know about the Rutherford with their gold foil experiment, okay, revealed a groundbreaking truth. Atom word, atom is not only a solid sphere, okay, as once do not thought. Instead, they had a dense, positively charged nucleus surrounded by vast empty space. Okay, I know. Atom also have empty space. This is the nuclear. Like assume that this is the nuclear of that atom, and the electrons are traveling in a pattern around this nucleus, and in this they have a tiny space, very tiny space, very tiny space. We can't imagine that. Okay, so okay, so Alpha particles are being deflected, some even bounce back, and if they're hitting something incredibly dense at the center of the atom. The other four work help explain radioactive decay. He identified three types of radiation: alpha, beta, and gamma rays by this experiment, okay? Each with unique properties. Radiation was no longer a mystery, it was a fundamental part of nature, okay? It was a very natural thing about like we are not like doing nothing, we are not doing any reactions, we are just doing a natural kind of delay, decays and reactions, okay? So, radiation story took a dark turn during World War II. Now, listen to me carefully. In the race to harness nuclear power, the United States launches a Manhattan project, a top secret program to build an atomic bomb. Here's the World War II happens. The Cold War, like a nuclear war. Okay, don't call war. Okay. So, hmm, brilliant minds like Robert Oppenheimer, the first nuclear bomb developer. Okay, Oppenheimer. You watch the movie also of that Oppenheimer with like Robert. No. Killian Murphy. You know about that. Hmm. And Enrico Fermi. Enrico Fermi worked day and night, unlocking the devastating potential of nuclear fusion. Okay, in 1945, the world witnessed the horrors of nuclear radiation, and when bombs were dropped to Hiroshima and Nagasaki. We know about that event, very ridiculous and like very harmful bomb destruction. Okay, the immediate destruction was catastrophic, but the long-term effect of radiation exposure, burn, cancer, mutation painted an even grimmer pictures. Okay, but radiation is it is just a harbinger of destruction, harbinger of destruction. It potential its potential for good in is immense. Okay, in medicine, it is a lifesaver. Okay, used to treat cancer, a diagnostic disease, through imaging techniques like CT scan and PET scans, like in which we use radiation to scan our whole body and find the flaws. Okay, industry in nuclear reactors generate clean energy, powering millions of homes. We also generate electricity by nuclear fusions. Okay, but it costs very much. Okay, but it because it like emit only steam, water stream, so it is very natural. Okay, today scientists are pushing the boundaries of what radiation can do for studying its effects. Astronauts in deep space to exploring its role in a clean fusion energy. Radiation remains a frontrunner of innovation, yet we must proceed with caution. Okay, radiation tale is one of a duality of creation and destruction, a light and shadow. It is a phase that has shaped our past, defines our present, and will undoubtedly influence our future. But as we move forward, let us remember with great power comes with a great responsibility. So, that's today for the radiation. We will meet in the next chapter of this book in the next video.